The heart is a muscle pump that simultaneously moves blood through the pulmonary circuit of the lungs and the systemic circuit of the remaining body tissues. The cardiac cycle is the alternating contraction and relaxation of the heart that moves blood through both the left and right sides of the heart simultaneously. Oxygen-poor blood flows into the right side of the heart at the right atrium. Blood passes through the right atrioventricular valve, or right AV valve, into the right ventricle. As the ventricles contract, blood is forced through the right semilunar valve into the pulmonary trunk. Oxygenated blood flows into the left side of the heart at the left atrium, through the left AV valve, and into the left ventricle. As the ventricles contract, blood is forced through the left semilunar valve into the aorta. Notice blood flows through the heart in one direction, from atria to ventricles and out large arteries. This is made possible by the one-way nature of the atrioventricular and semilunar valves. Imagine these valves are like your front door, which only opens in one direction, and it opens in response to the pressure you exert on the door while pushing. Heart valves work the same way. A buildup of blood pressure on one side of the valve causes it to open. However, pressure on the opposite side of the valve causes it to close, like shutting a door, preventing blood from flowing backwards through the heart. To force blood through the heart, the chambers must alternately contract, which is termed systole, and relax, which is diastole. A single cardiac cycle consists of 5 phases, each of which takes place during ventricular diastole, shown in blue, or ventricular systole, shown in red. The first phase represents the end of ventricular diastole, where the ventricles are relaxed and filling with blood. Once the ventricles are filled with blood, they begin to contract, representing ventricular systole, which forces blood into the arteries. The last phase of the cardiac cycle returns to ventricular diastole, where, after pumping blood out of the heart, the ventricles begin to relax again. Let's examine each phase of the cardiac cycle in more detail. Throughout the cardiac cycle, we'll monitor the volume of blood in the ventricles through time. Volume changes are the same for the left and right ventricles, so for simplicity, only the left ventricular volume is shown. As you might expect, blood volume decreases during systole as blood is forced out of the heart, and volume increases during diastole as the ventricle is filled again. The arrows indicate the beginning and the end of one cardiac cycle. The first phase of the cardiac cycle is atrial contraction, or atrial systole. Contraction of the atria tops off the ventricles, filling them to their maximum volume of blood. This volume is called the end diastolic volume, or EDV. Now full, the ventricles begin to contract. The next 2 phases of the cardiac cycle represent ventricular systole. The first part of ventricular systole is a very brief phase called isovolumetric contraction. Pressure in the ventricles begins to rise, which pushes the AV valves closed. But pressure is not yet high enough to open the semilunar valves, so blood volume in the ventricles remains constant. Iso means same, so this literally means the ventricles contract as the blood volume stays the same. You can see during this phase that ventricular volume remains at a maximum EDV. As the ventricles continue to contract, blood pressure builds and forces the semilunar valves open. Blood rushes from the ventricles into the pulmonary trunk and aorta. This phase is called ventricular ejection. As blood leaves the ventricle, the ventricular volume decreases. This continues until reaching a minimum value known as the end systolic volume, or ESV. This marks the beginning of ventricular diastole. As pressure inside the ventricles drops due to relaxation, the semilunar valves shut. but for a very brief period of time, pressure is not yet low enough in the ventricles to open the AV valves. So the volume of the ventricles remains constant. This phase is called isovolumetric relaxation. Notice there is no change in ventricular volume during this phase. Blood volume remains at a minimum because all valves into and out of the ventricles are closed. Eventually, pressure in the ventricles becomes low enough that the AV valves open and ventricular filling begins. Blood flows passively into the right and left atria, through the AV valves, and into the ventricles. Notice that during this phase, ventricular volume increases over time as the ventricle is filled. The passive flow of blood during this phase accounts for roughly 80% of ventricular filling. The remaining 20% of blood is forced into the ventricles during atrial contraction, which indicates the start of another cardiac cycle. In summary, the cardiac cycle is the alternating contraction and relaxation of the heart muscle that moves blood simultaneously through the left and right sides of the heart. This movement is always in one direction, from atria to ventricles during ventricular diastole, then out large arteries during ventricular systole. We began with the ventricles relaxed and in diastole. This period includes atrial contraction, which serves to top off the ventricles. Once filled, the ventricle contracts, entering ventricular systole, where blood is ejected from the ventricles into the pulmonary and systemic circuits. The ventricles then relax, entering ventricular diastole, where the ventricles begin to fill again in preparation for the next cardiac cycle.